you a tool that I like to use when doing distance time graphs and calculating speed in science, and that is Desmos. Students should be pretty familiar with Desmos. They use it in math a lot, and that's why I like the idea of utilizing it in science because it's something they're familiar with. So, a little quick overview of Desmos is once you click on the link in the iUp, you're going to be able to assign this to your class. So you can go to assign a single session code, and it's going to create a code for your students to join. Once I press teach here, the instructions will display for my student, and then they can go to student.desmos.com and they can enter the code right here to join your classroom. So I had already started this one, so it took me to where I left off, which is great. And look, so something interesting is there's 4 slides on this, and you can see I can't move from slide 2. This is the teacher dashboard for Desmos. So you can see if I'm on summary, it's going to list all my students for me here, and it's going to put a check mark if they've completed that slide or not. Now, I told you that I was locked in here to slide 2, and I can't go anywhere else. I'm controlling that as the teacher. So I'm going to stop this and then go to pace over here, and I can restrict them to 1 slide. I can open it and make more slides available. So, or I can progress this 1 slide at a time so it moves their screen to the next slide and they can't see anything else. So, like I said, I had answered question number 1 over here on my student screen. I'm pretending to be a student here. And it told me on the teacher slide that I was done. I can go to the teacher tab up here, and it actually shows me my students' answers, and I can do show correctness. And it should list multiple students' answers under here. What I like is if I'm not much of a math person, I can actually type in what I would do to do the math. Like, this one right here goes with 15. I know 15 minutes is a quarter of an hour. And so I'm going to take my speed and divide by 4. And I could just type it in like that, and it still took it as a correct answer. What that looks like on the student side in their response is there's this little calculator keyboard button, and they can type in numbers here. And that's how I was able to enter how I would do my math. All right. So now I can progress to slide 2 as a student, but I can't go to slide 3 because my teacher is restricting me. That is one activity. This one kind of goes through some basics of speed and graphing. Let's see. It even has some matching. So I can match the graphs with the amount of speed for each graph, which is great for calculating average speed from the graphs. And then this one is more interpreting the graphs and the motion. I've linked some other activities as well on the iUp, and these are a little more fun. So I would probably use these before the other one, actually, when I'm introducing motion and graphing. So again, I can assign a link and move through that with my students using the teacher slide to monitor where they're at in their progress and check for understanding. Let's preview this one really quick. So you used to be able to edit these. It looks like you can't edit them anymore, but students are going to be able to actually sketch a graph here. And I would encourage them to just explore this option. Maybe give them some challenges. Can you make a turtle go really fast? Can you make it go really slow? Can you make the turtle go backwards? They don't have to get all of these, but you could give them some challenges or just let them explore for a little bit. And then that's great because they can explore, they can play, but then remember, I can restrict their access. And so I'm going to make it to where they can't access this slide anymore so that they can't play anymore. And we're going to go to the next slide. They're going to predict what the object's motion could be. Then it's going to actually give us a video that describes the motion. This is where I would do like a turn and talk and have them talk about, well, what was the student doing in this section right here? So because you can't edit it, there's some slides you may not want, and you can just skip past them. Like students don't need to know what the motion does in a circle. Might be interesting conversation, but they don't have to know that. So you're free to just skip through that. But anyways, they get to keep going through here and interpreting graphs and creating graphs to match Turtle's motion. So it looks like he stopped for a little bit and then he starts moving again. So I'm trying to make a graph that goes with it. And then when I press play, you can see there's going to be two turtles. And if those two turtles match up, I've drawn my graph correctly. Okay, so the silhouette is the actual motion I'm trying to match. When I draw my graph, then that is a dark colored turtle. So I'm going to let my students play. Oh, my turtle needs to go faster at first. So I'm going to start over. I'm going to make my turtle go faster in the beginning than it did at first. Let's see if I can do a better job at matching it. Oh, look, I did a better job. Maybe needs to go a little bit faster. It stopped. Oh, and mine kept going forward, and I missed that one went backward. Anyways, so this is a fun way to introduce it. My students always enjoyed it. Again, I've linked a third activity as well that does some more things with the turtles. And this actually introduces multiple turtles instead of just the single turtle. And those turtles are racing. And then this is where they can see how the slope of the line further connects to the speed of the turtle. Anyways, fun resource to try and pretty easy to use in the classroom and monitor progress with.